Today we will discuss the minimization of boolean expression using Carnot maps. Before that, we discussed the minimization of boolean expression using boolean laws, using basic theorems and De Morgan theorems. So what's a K-map? K-map is another technique to minimize the boolean equation. It's a graphical method, we can say, having some boxes. Whatever the information that is in the expression is represented in the K-map. So there may be 2 variable K-map, 3 variable K-map, up to 6 variables. So the maximum size of the K-map is 6 variables. Here we can see the structure of 2 input K-map. So here are 2 variables, that is A and B. Both variables can have the values 0 and 1. So there are the inputs or variables and values are 0 and 1. So inside the boxes, what we do, we enter the output inside the boxes. So the 2 input K-map, there are 4 boxes, because we know for the 2 inputs we have 4 number of combinations like 0 0 0 1 1 0 and 1 1. Here it is showing the structure of 3 input K-map. 3 inputs are A, B and C. Here we can see here the A can attain the value of 0 or 1. Similarly, the value of VC can be 0 0 0 1 1 1 and 1 0. You can see the order 0 0 0 1 1 1 1. It is not the order of binary number. It is like gray code. Okay, so 3 variable K-map consists of 8 boxes, 1 2 3 4 5 6 7 8. However, it is not necessary to put the A, B and C like that one. So the position of the variables or input may be interchangeable. We can put here A and B and C also. So these are the value of B, C. In the next slide we will see the structure of 4 input K-map. So in the 4 input there are 4 inputs like A, B, C and D. These are the values of A, B, 0 0 0 1 1 1 and 1 0. Or this is showing the value of CD 0 0 0 1 1 1 and 1 0. So 4 input K-map having 2 raised power 4 means 16 boxes, 1 2 3 4 5 6 7 8 9 and so on to 16 boxes. So how the cell numbers are written in the cells, we can see in the 2 variable K-map the cell numbers are like that. 0, this is the 0th cell, first cell, second cell and third cell. So we can also see from the decimal equivalent of the binary. This is 0 0, so its decimal equivalent is 0. 0 1, so its decimal equivalent is 1. 1 0, so decimal equivalent is 2. 1 1 3. For the 3 variable K-map, the cell numbers are written as 0 1, then 2 3, 4 5 6 and 7. So here we can also see that all these cell numbers are the decimal equivalent of the particular binary. So we can say the decimal number is equivalent to the intersection of the binary number, like that. 3 is the equivalent of 0 1 1. 7 is the equivalent of 1 1 1. 6 is the equivalent of 1 1 0. So for the 4 variable K-map, we can see here 0 1 2 3 4 5 6 7 8 9 10 11. 8 means 1 0 0 0. 9 1 0 0 1. So 9 is at the intersection of the 1 0 0 1. So the binary number is 1 0 0 1. So the cell number is 9. So we can say in short, the cell number is the decimal equivalent of the binary number. Now how we make the K-map or how we plot the K-map for a given truth table. The figure shows in the slide there is a truth table of 2 variables 0 0 0 and 1. So how 0 0 0 1, so how we enter the value of output in the K-map. This is 0 0, for the input 0 0 the output is 0. So we can see this output is going in the 0th box. So we can say the 0, which is the output for the inputs 0 0. So we can say here 0 0 inputs and 0 output. 0 1 input, 0 output. 0 1 inputs, 0 output. Similarly 1 0, for 1 0 output is 0. So there is 1 0, so output is 0. So outputs are at the intersection of the inputs, we can say. For the 1 1 output is. Similarly for the 3 inputs we can see here, outputs are like we have chosen randomly the outputs like 1 1 0 0 1 1 1 0. So this one is the 0th, this one is the first, this one is the second is going here like 0 1 0, and fourth one is the 0, and this one is going here, this one is going here, this one is going here, and this 0 is coming here. Similarly we can draw the K-map. We can enter the values of K-map, values in the K-map from the truth table. So now we move towards what's the literal, minterm of n variables. So first we discuss about the literals. So any variable or its complement is called a literal, like A is called literal, B is called literal, A bar, B bar are called literals. Simply a variable or its complement is called a literal. Minterm of n variable. Minterm of n variable, it's a product of n literals, A B, A B C, A B bar C, A B C bar. The most important thing in the literal is that minterm of the literal as they add. So variables appears only one time, either in its true form or it's complemented, but not both. It cannot be there like A bar B. It cannot be there. A B C, A B bar C. Different literals are there, and the value is equal to 1 for each and every combination. In every K-map, each cell has a minterm, like we have seen here. This is the minterm for the A bar, B bar, C. This is the minterm for A bar, B bar, C. This is the minterm for A bar, B, C. This is the minterm for A bar, B, C bar, A, B bar, C. Each cell has a minterm associated with it. We can see it here the example for cell number 13. The minterm is A, B, C bar, D. We can see here 13 number. So this is A, B. This is 0. 0 means C bar and D. So for 13 number cell, it is minterm is A, B, C bar. For the 15 number, it is A, B, C, D. For the 12 number, A, B, C bar, D bar, and so on. What's the max term? The max term is the sum of n literal. Like the minterm was a product of n literal, sum of n literal is called the max term. So it is also had the same property. In the max term, each variable comes once, either in true form or in complemented form, and the value is always equal to 0. The value of the minterm was a 1. Here the maximum for the max term, the value is 0. So see, for every K-map we can see each cell corresponds one max term. Like for the 4 variable K-map, the cell number 13 was showing the minterm A bar, B bar, C, D bar. Here A, B, C bar, D, sorry, and here we can see the max term is A bar, B bar, C, D bar. We can see here from 13 number cells. This is A bar, B bar, C 0 for C for 0, and D bar. So wherever the 1 is coming, we can take the complement. Where the 0 is coming, we will take the true form. D bar. So what's now adjacent minterms or max terms? In K-map, the corresponding cells are said to be adjacents. Like that, we can see from here. These two cells are adjacents. These two cells are adjacents. These two cells are adjacent. Also, this and this cell is also called adjacent cells. This cell and this cell is also called adjacent, because by folding the K-map from here, this will overlap to this one. This will overlap to this one. So these are called the adjacent. In the 4 variable K-map, we can see these. All these are adjacent cells. All these are adjacent cells. This, 0th, 2nd, 8th, and 10th are the adjacent cells. 3rd, 7th are the adjacent cells. So we can say the adjacent cells are in the K-map, which are one after the another. We have seen here this adjacent in the K4 map. Now there is an example, 4 variable example like this one. The output are given 1 0 like this one. Now we can write this truth table in the form of expression. So f is sum of minterm. This is the sum of minterms